Hey everyone, and welcome to episode number 10. Number 10, we've gotten all the way to episode number 10 of your favorite show and ours as well, Not Another Demo. I'm joined today, as always, by Anthony and Lloyd, and today we're going to be talking with NCipher. So we have Steve Mogul, David Wakeman, and Tim Wilson from NCipher. We are going to be talking about certificates and some other fun stuff, right? So as everyone should probably know by now, but Not Another Demo is our attempt at having a real conversation with a vendor. The ground rules, as always, is no acronyms, no marketing jargon. If you use any of that stuff, we will probably call you out on it, ask you what that means. If we use it, which does happen from time to time, you guys can also call us out on using acronyms as well. So with that, Steve, I'm going to pass things over to you, let you introduce yourself and your team, and then we will get started from there.
My name's Steve Mogul, and I'm the Regional Sales Manager for NCipher. We do have a new name. We have, based off the acquisition from Thales when Thales spun us out, we have now become part of the Entrust family, and Entrust has officially renamed us Entrust. So the NCipher name by the end of the year will be disappearing. We'll all be going by the Entrust name, and I will be with the Data Protection Unit. Joining me is David Wakeman. David, I'm going to let you introduce yourself.
Hi, this is David Wakeman. I'm the sales engineer supporting the upper Midwest region and support Steve Mogul.
Tim, do you want to introduce yourself?
On camera, I like it.
It'd be great if I unmute myself.
I do some of my best talking on mute, actually. When I'm on mute, I'm really smart, and then I go off mute and things take a turn. So
yeah, and my voice sounds so much better. But when I have the camera off, I actually look better too. I kind of like the whole camera off thing, but then when the camera's on, then I got to put makeup on, and so I try to stay away from that a little bit. But to introduce myself, I'm Tim Wilson, channel manager, covering everything on the east side of it. So I work in tandem with Steve. I'm here, so glad to be part of this. Very excited to work with everybody.
Yeah, so this is a total free-flowing conversation, but as always, the one question that I do like to start with, and David, I'm going to throw this one at you, as nobody is really traveling right now, so we have more meetings because there's no travel time involved, so there's more meetings on everyone's calendar. Vendors are out trying to get meetings with clients more than ever, so all of our calendars are booked solid. So explain a little bit to me, like, given all of that, why would someone want to make some room in their calendar to talk to NCipher or Entrust, as we find out here moving forward? So explain that, like, why? Give us a little bit of that.
Well, with everybody working from home and things going in a different direction from our world today, encryption becomes very, very important. And, one of the things that we like to talk about is do you know where your keys are? I mean, bottom line is that if you're not aware of where your keys are, then guess what? Somebody else is, and that's a hacker. And that's what we like to talk about is the avoiding that hacker nightmare that other companies are dealing with these days.
So everyone has certificates in their encryption and the keys. And can you tell us a little bit, like, how how do I word this? Like, how big of an issue is this? Like, do you find that most companies have keys that are out there that are not being well encrypted? Do companies not know that they have or protected? Sorry. Do companies have keys out there that they don't even know that are not being protected? Can you talk through that a little bit?
Sure. What we find is that most companies will spend at least 85% of their security budget on the infrastructure and pay very little attention to the internal integrity of their network. Well, we know that the perimeter is breached quite often. And when you talk to a customer, when we talk to customers, if we ask them that question, 9 times out of 10, they're gonna give you that quizzical look, and most often they're gonna say, no, I don't know where my keys are. And so I would have to say that a good 90% of the industry that are using encryption, no matter what industry you're talking about, do not know where the keys are, because they figure, hey, I'm going to spin up this new application and I'll just let it create an encryption key for me and go on about my business. I'm happy. Problem is the key's in software. And when it's in software, then it drifts all over the place. And if somebody breaches your environment, that key's now vulnerable.
So how do you solve that problem?
Well, the way we solve it is we ensure that the key is locked down in a hardened device, something that only authorized applications or authorized users can actually access. The key never leaves that hardened device, so if a hacker gets into your network, they can't find the key because it's locked behind basically an environment that is not penetrable.
So you act as a certificate authority internally, or you're just storing private keys? Talk to me a little bit about the architecture there.
Sure. Our product, which is called a hardware security module, or an HSM for short.
I was going to try to get you on that one too, but well done.
I listened to you.
I was waiting for HSM. I knew it was coming.
Yeah. So I spelled it out first, so you can't gig me. But anyhow, our hardware security module is designed to encrypt private keys and master keys. Okay, so we generate those keys inside the hardware security module, and that's where they remain. Now, if you're in an environment like a PKI environment, that private key is locked down inside the HSM. The application, and I'm going to just use Microsoft's PKI environment, the application has access to it and will call out to it, but the key remains inside the HSM. The public key, of course, has to be shared, so that's out in the certificate itself. But when somebody makes a call, that application has to come back, talk to the HSM, and authorize that the public key being presented is actually valid to the private key that it was created from. It ensures that no man in the middle attack can happen.
So are you FIDO2, I don't know those acronyms, Matt, so I'm not going to. So are you guys FIDO2 U2F compliant? Is that the technology behind your hardware platform, or is it something?
I'm sorry, I didn't quite catch what you asked, Anthony.
So if I'm understanding this correctly, you're using a hardware key, right, to store and sign these, or just authorize these certificates, right?
Okay. I think I understand what you're trying to ask. Okay, the key that's generated, of course, is a digital key, okay? But the appliance that you generated inside of is a hardened device. It's an actual piece of equipment.
Okay, so we're actually talking about a physical box that is going to sit in my data center.
Well, we've got 3 different types, but the 2 that are most often used in networks are a solo card, which is a PCIe card that plugs inside of a server. And it's designed to work with one application and do all the work that application needs it to do from a crypto standpoint. And we also have an appliance, which we refer to as a Connect. Our latest version is the Connect XE, but it's an appliance, and it can talk with multiple different applications and provide crypto services to all of those applications. But the bottom line, it is a piece of equipment. It is an appliance. It is hardware. And the digital keys that you need to create to protect your applications, your services, be it IoT, be it SSL, be it databases, or anything else you can think of, those keys are generated inside that box and only made available to the applications that you've authorized the utilization of that key.
Got it.
Okay, does that cover? Okay, good.
I think the other important thing is David had mentioned that those appliances are in your data center, but our NCIO Connect can also be offered as a service because we do have a cloud offering. So that physical appliance is now in our data center that you can utilize like any other cloud type of service.
So could you speak to some of the advantages of bringing in an appliance like this to your data center versus provider managed keys and using their key vaults?
Well, yeah, there is a huge advantage to using a hardened device like this versus a provider's keys for generation. Okay, so we'll take AWS, Azure, or Google as a cloud provider and how they work. Okay, so when you generate a key using AWS's key management or Azure's key vault, they own your key, which means they own your data. Now, so if a situation comes up where the federal government or some other entity comes and says, I want access to their data, they're under investigation, I want access to their data, and I want access to the key so I can read that data, do you think Microsoft is going to tell the federal government no, or AWS, you know? No, they're going to give up whatever they have to save themselves. They don't guarantee that they're not going to. But when you generate the key, your key, and then make it available inside that environment, now you control the key. They don't. So they may release the data, but you've got the encryption key, so they can't decrypt it. So you're still protected, even under those circumstances. So somebody's got to come to you and get you to give them the key.
I think there's a couple other advantages of bringing your own key to those cloud providers. One is, what happens if you have a multi-cloud environment? You don't want to put all your eggs in one basket, and you want to use both Azure and AWS. Well, now you can generate one encryption key, utilize that same key in both cloud providers. So if you said, I don't want to use AWS anymore and just want to use everything in Azure, you don't have to decrypt all your data. Download it, re-encrypt it, and send it back up. So again, if you start looking at a multi-cloud strategy of having one key to manage all that information, that's an easier way to go.
Okay, so in that case,
Again,
talk to me about security and availability, because at this point, you are a single point of failure for my environment. If your, appliance goes down, or I can't get the key, I can't decrypt my data, and therefore I'm down. Same thing goes for, you've said that this is a hardened device and that, it's going to protect us from threat actors, but what do you do to ensure that? Do you conduct regular pen tests, code reviews? What does that look like?
So there's a couple things. I'm going to let David kind of go more into the technical side of it. But I think one of the important things really is that no one buys one HSM because, again, for high availability. So if one fails, the other one's there in being able to do that. There's some unique things technically about our architecture that allows you to easily back up those keys. But again, if you've uploaded that key into that cloud provider, the key is already sitting there. You can just revoke that key if it's not making a call to the HSM. David, I'm going to kind of let you kind of go into more technical details.
Okay, so whether you're buying HSMs on-prem or you're doing a subscription base to our cloud services, our Enshield as a service, like Steve said, you're going to have multiples of it. You're going to have at least 2 units, whether it be in the cloud or on-prem. One of the things that Steve mentioned was about being, using a multi-cloud environment. When you're using our Enshield as a service, this really comes into play because we're agnostic. We don't care what cloud you're in. You can actually use the same key generated for all 3 environments. So you may have data in Azure and you got a backup of it in AWS. You don't have to generate separate keys for that. Or maybe you're working with Google Cloud and they make you mad for some reason. You decide you want to move to AWS or Azure. When you have to do that, you're going to have to decrypt the data, download it back into your on-prem, and then re-encrypt it and load it up into the other cloud. With our Enshield as a service application subscription, you actually have the ability to move data across from one cloud to another without ever decrypting it, without ever exposing it to that process, because you can use that key in multiple different locations. Because of that, we give you redundancy, we give you resiliency, and we give you, again, high availability. The way we work with our NShield as a service subscription is we actually have multiple data centers, 2 in the UK, 2 in the US. And when you subscribe, you get 2 HSMs, and you control them completely, or they're yours to use through the subscription. One will be in one will be in one data center, and then you choose where you want the other one. So if you got an all US environment, then you're going to have an HSM in Dallas and an HSM in Denver. So in case one of those data centers were to go down, you would be still able to access the keys, use the crypto services. And we have customers that actually have services in the UK and the US. And when we do that, they'll set up something in the UK and something in the US. And again, because of the way it's designed, you still have access for whichever situation may occur. If you have a break between, say, the US and the UK for some reason, an outage, you still have the resources available to make sure that you're going to be available. When you're on-prem, you've got multiple HSMs in your data center, and they monitor each other. Our software, our management platform that takes care of all of this, continually has communications with the HSMs. So I call it a keep alive, but that's really not what it is. It's an interaction between them. And it tracks what's going on. If it sees one of the HSMs can't be reached for some reason, it will automatically redirect to the other HSM. It does load balancing for you, so you don't ever have to worry about one HSM being overloaded if you've got a high transaction per second environment. So you've got the ability to control your environment and ensure that you don't have to do anything manually to make sure that your crypto is available for those applications. And I kind of got long-winded, but I hope that gives you a good understanding of where we're at.
The second part of my question was how do you ensure that these devices are as secure as possible? Do you do code reviews, pen tests? What's your development lifecycle process look like?
All right, so they're tamper-resistant devices, okay? So if somebody tries to tamper with one, it will recognize that automatically, flush everything out of the HSM and shut down, and there's no way of recovering from that. So if somebody tries to open the cover of an appliance, it automatically shuts down, it flushes everything from the appliance and goes basically dead. You're done. With the solo cards, the ones that are plugged inside the server by itself, you can pull that card out, but if you try and tamper with the secure environment around the crypto engine, again, it will recognize that and shut itself down and will never allow you to use that device again. So it is tamper resistant, and it has preventions built into it to ensure that somebody can't get in and actually mess around with it.
I think the other thing is that these go through extensive testing through NIST for the FIPS compliancy and common criteria. So again, there's tons of reviews, independent reviews, because this is one of the most important things in your environment of protecting your encryption keys.
Right. Yeah. The hardware, the firmware, the software all goes through extensive testing to ensure that we meet the highest standards.
Yeah, so when we think about these, I almost like to look at these keys as identities. It's, you need to manage them similarly. You want to make sure, just like you wouldn't have your administrative service accounts or administrative accounts running around without some sort of control process, you need to manage that. Mm-hmm. So what changes would an organization need to make to start managing their own keys?
Well, it boils down to their security policy. I mean, when you're generating a new key, you set down rules based on your security policy within your company. And we have 3 different ways of protecting the key once it's generated or through the generation process. And what happens is, based on whichever one you use, there's metadata that gets added to the key structure that identifies how and what is authorized to use the key and how that is applied. Now, you can set up a key generation to be module protected, where the HSM has responsibility for protection. You do stuff like that for like web services and stuff where you don't want to have to get somebody out of bed because they had to, they had to do a software upgrade or something on a web server. Okay, you can do what we call soft card protection, which is basically passphrases, and you set up a quorum. So a quorum would be, say, 1 of 3 or 2 of 4 or 5 or something of that nature, where multiple people have to be engaged to authorize the spinning up and utilization of that key. Once that's happened, the key remains in the HSM and is available until the application is taken offline, or the HSM has to be restarted for some reason. The third way is we use smart cards. We call them operator card sets. Again, you would create a quorum based on the security policy. So that quorum would then dictate how you authorize the utilization of that key. The metadata would dictate what can utilize that key. Does that make sense? Answer your question?
Yeah, thank you. Yeah.
So if I circle all this back around, just listening to the conversation here, which has been great. So we have a lot of, and Lloyd and I have been working on our CCSK. Now I'd be using an acronym. I'll blow it.
What's that acronym?
Oh gosh, I knew you were going to ask me that. So
caught in our own trap.
It's like Cloud Certified Security Knowledge. I'm going to have to double check.
Certificate of Security Knowledge. Yeah, Cloud Certificate of Security Knowledge. But we're talking a lot about encryption in there. So from a business issue standpoint, it sounds to me like there's a lot of companies, probably most, or if not every company, has applications or systems that they're going out and they're encrypting and they're creating these keys and probably thinking, I've done encryption, so I'm doing something good here, right? But as that spreads out and they have more and more of these keys and they don't have good security around them or any way of centrally managing them, that's when they're starting to get into trouble. Now that sounds like, to coin a phrase, really bad security. But am I catching? I mean, is that the business?
I think you think about that, and I think I'm going to give you 2 great examples, and these are fairly recent data breaches, and I think that kind of puts it in perspective because a lot of companies are doing the right thing, but they didn't take that next step. Right? So one, we've all received the notification if you've traveled at all and stayed at a Marriott property. About 2.5 years ago, Marriott experienced a breach, and it was the old Starwoods database. And if you go back and read the breach notification they sent to everybody, it tells you that how they protected the credit card information with AES encryption. But the next sentence, because again, they were talking to a lot of people that are not in the security space, not in our business, it says it takes 2 things to decrypt that credit card information, and we're not sure whether they got both. Well, we know what those 2 things are. One's the data. The second one is the key. So as we kind of talked about, what happened is they protected the information by encrypting it. What they stole was the encryption key, right? So if you think about, we did 95% right. We didn't get that last 5% was protecting the key because they go, who's going to find that key? Another one was a little over a year ago was Asus computers. Asus, again, did everything right. They had they were signing all their firmware updates so they could, the end user could validate that it really came from Asus. But what happened is they didn't protect the signing key. So the bad guys got into Asus. They posted some malware as a firmware update. They used their signing key, and over 1 million people downloaded what they thought was valid Asus firmware update and updated their computer with malware. So again, doing everything right, what we needed to do was go to that next step of protecting what we're doing for protection, right? So those are some examples I like to use because I think it makes it real for people going, oh, I thought I was doing everything. There's that next step that we have to follow up with, right? So it's that next level of protection.
Yeah, and I think that's what we're finding a lot. I mean, I joked earlier, but our other series that we're doing is called Really Bad Security. And I think what we're finding through some of that is there are some practices that we have out there where again, people think they're doing all of the right stuff or, what we've been told to do, and we're doing those things, but in actuality, maybe not, or maybe we're not taking it far enough, or we feel like we've gone far enough down this path, but for the hackers and everyone else, like they're willing to go the extra step beyond what we've been told to do. And if you're not, as a security person, taking that same step, then you're leaving yourself vulnerable. So, and the finances of all of this, right, is and being Security Awareness Month is like topic number one right now. But the dollars behind of being the good guys versus the financial possibilities for the bad guys is astounding. And so if we're not looking at really fully taking our security all the way to where it needs to be, really.
Well, we find out encryption keys are pretty easy to find, and I don't know if you can bring up the two slides I brought one at a time. And you've seen this before, Matt, so I'm not going to ask you the question. But Anthony and Lloyd, here's the important thing. Can you find the encryption key here? Yeah, this is 5 blocks of memory that were taken out of the computer. They were frozen. It's the most random thing that you can find. Can you identify where the encryption key is?
Anthony, what do you have?
I got nothing.
Yeah, it just looks like gibberish.
Pick one.
Pick one.
Pick one.
I'm gonna go with 3.
You got
3. Anthony.
I'm gonna say 2.
Okay.
Ooh.
Roll, please.
Ooh. You owe Lloyd lunch.
Lloyd wins.
It's 3.
Awesome. Luck is on my
So,
side.
but think about this. We're not bad guys. We're good guys. You found the encryption key in under 30 seconds.
Mhm.
Guys that are professionally looking at your environment, they're not, think about a burglar. What's a burglar going to do when they get to your house? First thing they're going to do is go to the front door and see if it's unlocked, right? And they see the front door is locked. They're going to walk around the back door and see if the back door is unlocked. Then the next thing they're going to do is lift up the mat and see if the key is underneath there, or go around the door frame, or look underneath the pot. No one today is breaking the encryption algorithms. What they're looking for is to steal your encryption keys. And that's where, whether it's both, this is, cloud security, we're talking general security, because it doesn't matter whether your data is in the cloud or on-prem or a combination of both. Where's that encryption key? Where can they potentially find that encryption key? Because that's what they're looking for. Most of these data breaches someone doesn't get into your environment and just start doing this stuff. They're there for months. They could be there for years, and this is what they're looking for. So that's, that goes back to almost that Marriott breach. They've been poking around there for almost a year and a half, I think, till they found some stuff, and wham, bam, thank you, ma'am. Now you got a huge notification issue, and from that standpoint. So again, you start thinking about it, people are inside the network. No one can stop a breach unless you cut the wire. And even then, someone internally may do something by bringing something in, and you have a different type of breach. But what they're looking for is, what are all the pieces? How do I start stealing that valuable information that you have, which is your data?
So easier to find and steal the key than it is to break the encryption. Did I catch that correctly?
Yeah.
While they're going at it.
Right.
So quantum
Just
computing
find the
comes out
key
of
and
it.
not worry about, instead of breaking the window,
Don't worry, there's
just look at finding the key and walk right in.
Don't believe everything you see on TV or in the movies. Give me 30 seconds, I'll crack that for you, and the world won't blow up.
So one of the other things that I like to talk about in this, at least sitting from my position, is in dealing with a company, the number one reason why I see companies or technologies being displaced right now is not the technology, not the pre-sales, none of that. It's actually the post-sale support, the working with an organization is really, to me, the definition of a good company, a good security company and a bad company. Everybody's product has, good stuff about it. Some better than others, I suppose, but we're all in business for a reason, or all the companies are. Can you guys talk to me a little bit about what it's, what it's like working with you guys, a little bit pre-sales, like what would that look like going, hey, I want to see how this works, all the way through to the post-sales. And then, let's talk a year from now, 2 years from now. What is it like partnering with you guys?
I think from a pre-sale standpoint, between David and myself, we really need to understand from a customer standpoint of what problems are you trying to solve. We don't always kind of talk about that, but again, sometimes people don't realize the problems they have. So we really need to talk about encryption. What are you doing in your environment? How you're trying to do different things. We're seeing a lot of things bubbling up in the IoT space. And so really, what's your strategy around these things? And then really comes down to being the root of trust. So we kind of go through that whole sales process, understand your environment, your goals, what you're trying to accomplish, the tools that you're utilizing, because no one buys a hardware security module and installs it and says, I have a hardware security module. We're always tied to an application or another security device. So it's really understanding those types of points of integration that you need. So David and I really kind of take it from start to finish from a sales perspective. Customer purchases our product. 9 times out of 10, they're utilizing our professional services organization, which is top notch in helping do the installation, training. A lot of times they may utilize us for custom work that they may want to do, like using our code signing gateway, which puts workflow around code signing or some IoT or custom cryptographic solutions. Everything's up and running. David and I continually stay in contact with our customers, keeping them up to speed, up to date. There's always new projects, new use cases they may have. And if there's any ever technical issues, we have a top-notch technical support department that's basically available based off of the maintenance agreement that you bought 24/7, 365 with our own people. We follow the sun. We have support centers in the US, the Far East, and in the UK. So you may open up a trouble ticket in the middle of the night. It may start in the Far East, get passed over to the finish up in the UK, and may get passed back here to the United States. So we got you covered 24/7, 365. If customers are doing some updates, they typically open up a trouble ticket and say, we're going to do an update over the weekend. Just want to make sure that we have support available to us. And our guys saying, let's kind of walk through all the steps ahead of time. But if you need us, we already have the trouble ticket ready to go. Just make the phone call. We're good to go. So, David, I don't know if you want to add anything else.
I think from a pre-sale standpoint, Matt, we're looking to find out what the pain points are and how we can fit into what they're trying to accomplish, because they're looking at applications. They're looking at, privileged access, or they're looking at, spinning up a new public key infrastructure or whatever it is. We need to find out what it is. We don't, we come in to provide additional support for the things they're already trying to accomplish. I mean, like Steve said, you don't buy an HSM and put it on the shelf and say, hey, I'm protected, now I got an HSM. We need to understand what application or applications that you're concerned about or that you feel may be vulnerable. And then we can help guide you on what's the best solution for that. Sometimes it's us, sometimes it's not. But that's what we're trying to accomplish. Once we know that, once we understand that, and we can provide a solution, then we're going to guide you through that whole process. We're going to work with people like you to ensure that the right marriage comes together, that you bring in the right applications, you bring, and we bring in the right connectivity to ensure that that application has the highest level of security possible, so that they can go home at night and sleep, and feel good that the things that they're trying to protect are truly protected.
I think the other thing is we take a look at and just make people aware of other things that maybe that you don't really think about encryption. So if you were looking at a privileged access management solution, you're going to think, encryption? No, I got privileged access management. Well, that whole environment is when you protect it and create that master password is basically encrypting that whole solution. So that's where people sometimes may not think of all the other pieces of the puzzle, because they may only think about, hey, we're starting with a public key infrastructure, because I wanted to say PKI, but I stopped myself. So there's different things out there that people may not even realize that are doing encryption behind the scenes and protecting the master keys.
Yes, good stuff. Anthony, Lloyd, anything else? I'm checking time and we're kind of hitting up against our half an hour here. So, yeah, with that, go ahead.
Nope, so I'm good.
All good. All right. Yeah, I mean, to me, and having, spoken with you guys a few times over the last couple of weeks, it's definitely been a learning process for me. I mean, again, I feel like a lot of people are probably out there thinking that they're doing encryption and that they're, that they're doing the right thing by their company, and they certainly are. But if you're still leaving something out there that's available, if you're still hiding your key under the front, Matt, you're hiding it under me. It's not a good place to hide it. Then, maybe you're not doing the full service that you should. So, so if anyone is out there that is, is not sure if you're fully protecting all of that encrypted data and you do not have an HSM in place, hardware security module, I had to write it down because I was going to blow it otherwise. But we will have in the description of this episode all the different ways that you guys can connect with NCipher, or soon to be Entrust. With that, hey, thanks for watching this, everyone. Please do the like and subscribe and share and all of that sort of good stuff. And we will see you again real soon for episode 11. Thanks, everyone.